Hello, this is the AR Mural project. I'm Pavan.
I'm Arya.
I'm Nicholas. I'm Alexander.
And I'm Anna. So the objective of our project was to create a collaborative application where artists can create and share their work in real time. And in order to enhance the user experience in the app, our main priority was to minimize latency. And additionally, we wanted to create a customizable creative environment. And so we did this by providing various settings and tools that could be modified according to the user's preferences. And then ultimately, we planned to deploy the app on the open AR cloud so that it could be accessed from any location.
First thing we worked on was a drawing. We used the line renderer feature to create to render lines using control points. We worked on a hand menu that includes a color picker and different tool settings, including thickness and texture. And we worked on mesh generation and object manipulation.
So after creating like the fundamental drawing tools, we started working on the actual collaboration part. And we decided to go with a JSON saving format where basically we would take all the line render and the game objects in the scene and basically convert them into JSON data and then save them to a file on the device. And then from there to actually send it to other devices, we decided to use a MQTT broker, which is basically you have multiple devices subscribe to some sort of topic, and this broker or server would hold these messages that the devices send. And in this case, it would be JSON files or JSON data. And then once it's sent, other devices would be since they're subscribed to a topic, they'd receive the messages and basically get this JSON data. And then from there, we would unpack it and basically put it back into the scene, which is our collaboration part.
So along with the pub/sub architecture, we had different softwares that act as clients to manage the MQTT broker. Node-RED was used to manage the topics within the MQTT broker. We also used MQTT Explorer or Manager to see what was happening in the broker, such as seeing what messages were sent and how many clients there were. And finally, we created a file server client using Flask MQTT, which is basically an extension of Flask, which is a Python micro web framework. And basically, the file server just saves JSON messages from the MQTT broker.
Some basic software challenges we had was actually initially just setting up the device we use to test the AR, which is our Microsoft HoloLens, and just getting that connected to Unity, installing like the specific drivers and making sure the controls actually work. And also just like using Unity, Unity's UI and C#, since most of us, I don't think, have actually used Unity before. So getting familiar with that was also a big challenge. And then also just merging all the different changes, since like Alex would be working on, say, the drawing textures or implementing new features, and then having that be able to save and actually work with the collaboration features was a big software challenge as well.
In our first prototype, we had fundamental tools to draw in 3D space and collaborative environment that allowed us to create drawings together in an import-export structure for GLB files.
So here we have like a quick demo of what the app actually looks like on the HoloLens. So here we have like the basic menu we implemented, and this is just like the initial drawing feature. And as you can see, the lines are being rendered when you pinch your fingers together, and you're also able to actually move your structures that you draw. We also created a shape feature where you're able to create like 3D solid objects. And here's more of a mesh tool. So basically it's like the line feature, except it creates a solid mesh around whatever you draw. And in this case, it was a star. We also implemented a sort of erase feature. As of right now, it erases the entire line object, but later down the line, we hope to optimize and create like smaller erasers. This is also another. And then this final part shows like kind of the collaboration. So one of us is like drawing on a laptop, and I'm able to see that through the HoloLens, and I'm also able to add to the environment.
So we would like to implement many future features later along the line. One feature that we would like to add is the AR Cloud utility. Right now, we're saving the drawings that we make onto a computer locally, but we would like to render those drawings that are saved into many different locations, and AR Cloud will help us do that. We would also like to optimize how we use the JSON data, because right now we have some latency within the project, and we would like to reduce that latency by quite a lot. One way to reduce this latency is by using a file server. Right now, we have a JSON object iterated throughout, and we iterate through that same JSON object, and changes are added to that same JSON object. And instead of just iterating through that same JSON object over and over again, we would like to iterate just through the change. And finally, we would like to create an undo button for easier deletion, because let's say you make a small mistake within your drawing. You wouldn't want to go through the hassle of changing tools and go into the eraser. You would want to have a small button to undo the change.
Which allows artists to create and modify sculptures. But in the future, there's the implementation created for mobile devices, which would allow sculptures to be viewed on the go and kind of create like this like fourth dimension environment for users.
We also have a demo during the poster session, so feel free to ask any questions and such. Thank you.